Hello guys, welcome back to a new video. A few months ago, I created a motion sensor system to turn on the LED and automatically turn off after 5 seconds. However, the LED strip operating in single mode and I wanted to be more versatile. So in today's video, I am excited to share you an upgrading version where the LED strip will illuminate in different patterns. So instead using this PR sensor, I am going to use IR Potentiometer sensor NPN. This way when someone is detected from the above, the LEDs will light up from the top. If someone is coming from the below, the LED will illuminate from the bottom. To add an extra layer of sophistication, when many people work towards both the sensor up and down simultaneously, 3 LED strips will light up. In this video, I am avoiding to use code. However, for those interested, you can implement this with Arduino Nano or Arduino Mego. Additionally, you can easily extend the idea for take it with more than 20 steps. And I am not using any custom design PCB in this project. So I am dividing this video into two parts. In first part, I will demonstrate how to build this circuit on the Zero PCB. In second part, I will show you how we can implement it into a staircase. Let's work toward the component required for this project. We will be using 6 pieces of IC 74SC5951N along with 6 IC base, 4 IC 55 timer, 4 IC base 4 timer, diode 1N407, 26 pieces of 547 transistor, 10K or 200K potentiometer, 2K resistor, 220K resistor, 100 megafarad 24 volt capacitor, 1 megafarad 63 volt capacitor, 10K resistor, 2 IR Potentiometer sensor, 1K resistor, 10 core wire and single strand wire, and some Zero PCB size like 2 by 3 inch and 125 mm into 100 mm Zero PCB. So these are the components we will be using. And also we will require a 16 channel 12 volt relay, and you can also use 5 volt 16 channel relay, and one more relay, 2 relay I am using 5 volt for extending this. For the power supply you require 5 volt 2 amps adapter, and for the power supply to the LED strip and the relay you wanted 12 volt 5 amps SMP. Let's start by placing the 6 IC 74SC5951N on the Zero PCB. After that, connect the VCC wire to all the ICs. Followed by soldering the ground wire to the each IC. Now solder the yellow wire to the pin 9 to 14 of the ICs. Attach the 10K to a pin 14 of upper IC first and the down IC last. Place 18 diodes between the ICs and solder them. Connect them according to this diagram. Now we will place two IC55 timer for the time adjustment and terminal for the power supply. Solder the VCC pin to 4 and 8 of IC555. Add 1 megafarad 63 volt capacitor between pin 1 and 2 and also connect the ground wire of first pin of IC. Add 1K resistor, 220K resistor and attach 10K or 200K potentiometer. Connect two 20K and 1K resistor from pin 7. Join them and link other end of 200K to middle of the potentiometer. Solder 1K resistor to VCC pin and connect the right of the potentiometer to pin 6 and short pin 6 and 1. Use a blue wire to connect pin 3 of IC555 to each of IC7 for SC595. Connect the pin to 11 and 12. Now place two 5 volt relay and connect the diode to pin 5 and 2 of both the relays. Connect VCC pin to 1 and 5 of both the relays. Connect pin 14 of 74HC5951N ICs to pin 3 of the relay. Place 2 more IC55 timer. Connect the VCC pin to pin 4 and 8 and add a 100 megafarad 25 volt capacitor and connect the negative wire to pin 1 of IC555 and also connect the capacitor negative pin. Place a 10K or 200K potentiometer and connect the pin 6 and 7. Also link them to a positive capacitor pin. Connect the middle wire to the VCC pin. Now place a 2K resistor, 10K resistor and BC547 transistor on the both the side. Connect the second pin to the 10K resistor and connect the other end to the VCC. Connect the third pin to the 2K resistor on other side. Then connect the other end of 2K resistor to middle of base of the BC54 transistor. Connect the collector of BC547 transistor to pin 2 of the relay. Connect the emitter of BC547 transistor to the ground. For the sensor, connect the two relay to the 0 PCB. Connect pin 5 of the relay to the VCC. From IC pin 3, connect to the middle pin of relay 1. Connect pin 2 of relay 1 to the pin 1 of the relay 2. Connect a diode between pin 2 and 5. Short pin 4 and 5 and place a 3 pin terminal block on the 0 PCB. Connect the positive wire to both the terminal and also the negative wire, and middle terminal block connect to the shorted pin of 3 and 4. Next, connect 18 BC547 transistor and solder them and connect the emitter to the negative and base to the relay. Now collector to the 18 1K resistor and 1K resistor to the diode.